This video is to showcase two things. One, what does paired differences mean? So what does getting D bar look like? And then two, how do I use the GeoGebra confidence interval calculator? Let's start with D bar. So here we have 8 subjects and we have measured their upper arm and their lower arm. And this is, I should say, in inches. Should have included that. My bad. Now, what you want to do is you say, oh, I want to take the mean of this, I want to take the mean of that. But what we're doing is we're looking at differences. So it doesn't matter which way I subtract. I could choose to subtract the lower arm from the upper arm measurement or the upper arm measurement from the lower arm measurement. But in either case, I want to put the difference. And so what I'm going to do is, because I can see that my upper arm in each case is the longer measurement, I'm going to go ahead and subtract the lower arm from the upper arm. Actually, let's go ahead and tell ourselves this is the upper minus the lower. That might make it easier for us to come. We're going to make things easier for ourselves so that when we come back and we're trying to explain to ourselves what the confidence interval means, what the confidence interval is telling us, we have these clues to tell ourselves. So we might say D bar is the average difference between the upper and lower arm lengths. And I'm going to remind myself U minus F. And then that way I know when I have a positive number, that means that the upper arm is the longer of the two. And when I have a negative number, that means that the lower arm is the positive of the two. So let's go ahead, or the larger of the two. I'm going to go ahead, and it knew what I wanted to do, but I'm still going to just show it to us because I kind of hate it when Sheets is like, oh, I already know what you want to do. Sometimes it's too smart for its own good and I go along with it and it's not what I want. So I'm going to hit equals. What I'm going to show you is you can either click on it, and that's my B2, and then hit minus and click on the cell C2, or you could have typed it in equals B2 minus C2. Now notice in both instances, it is highlighting my cells. So you can see that matchup of the orange to orange and the purple to purple. Because I'm highlighted on the purple over here, that purple cell is highlighted. If I clicked on my B2, you can see that cell B2 is now highlighted. In any case, I'm going to hit enter. And now it's giving me a suggestion of autofill. I'm going to not click on that because I want to show you how you can autofill yourself. You can either click on this, and once you get that little plus sign, you can double click. Now it has to be set up nicely for double click to work. If double click doesn't work, what you can do is get that little crosshairs, click and drag. And either way, you do want to go back and double check. So I'm going to go up here into the equation editor and double check that it's highlighting the right things and doing the correct math for me. So sometimes when we copy down formulas, spreadsheets doesn't always play nice. At any rate, this is the this is where I want to be doing my math. So it's this new differences. This is where I'm going to find the things that I'm looking for. So I need to find D bar. I need to find the mean of that particular set of data. So I'm going to hit equals average. And now I'm going to highlight the data I want the average of. And so the average difference is 3.375. Now let's go look at our, well, we might remember that the other things that we need, because our general formula is D bar and plus or minus our, sorry, you can't see it, T star. So that's our multiplier from our T distribution. So what level of significance are we doing it? And then that is times our S, and I'm going to put that as a subscript. So S sub D, that's the standard error of, that's the standard deviation of that sample. I'm sorry, S sub D is creating the standard error, and then divided by, and the way you type square root is a weird thing. You type SQRT for square root, SQ for square, and RT for root. So the square root of N, which is our sample size. The things I need to create this formula is I need D bar. Well, I've got that. Go ahead and put that up for myself. My T multiplier, I'm actually not going to need for my calculator, so I don't have to calculate that. And I would look it up in a table anyway. That doesn't change from sample to sample. That only changes based on what level of confidence you're building your interval at. What I do need to know is I do need to know S sub D, and S sub D, again, that is how varied is my sample. So I'm going to say equals, because it's supposed to be the standard deviation of my sample, ST dev for standard deviation. Make sure you're getting this one and not one of these other ones. This is the one you want, ST dev, because it's the standard deviation of this sample. We're going to go ahead and hit enter. And so there's my standard deviation, about 0.8345 inches. I don't know how far out I'm gonna have to approximate that when I put it into my calculator. I haven't decided how far out I'm gonna do that yet. There's my S sub D. And then finally, the last thing I'm going to need is I'm going to need my sample size. Now here, I can easily count it. Now be careful, you might look over and go, ooh, it's 9 if you don't have this. Oh, if you have a header, remember that row 1 is row 1. So really your first thing is hitting on row 2. It makes me so sad when students go off of their row number and not off of this number. So it's really, that's why I put subject in here so I can see I had 8 subjects. If you don't know though, if you don't have that, the other thing that you can do is you can do this and you can say equals count, and it literally just counts how many cells you've highlighted. Make sure you don't accidentally count the U minus L, the subject line. Otherwise, you will be very sad. Okay, so this is everything I need. So what we're going to do is go to GeoGebra Classic. So this is geogebra.org/classic/probability. I love it because it's set up just like a TIA4. You just have to know what buttons to press. So right here, the statistics button. And now this is your go-to best friend. Now notice that all of these say test. We are not running tests. Right now we are running confidence intervals. So we're going to just bypass all the tests and we'll come back to them later. What we're doing is we're doing confidence intervals. Remember, a confidence interval is an estimate of a parameter. So all of these right here, these are your confidence intervals. Here's your Z confidence interval for a single mean, your T confidence interval for a single mean, your Z confidence interval for a difference of means. You can throw that one out, we'll never use it. Your T estimate for a difference of means. That's our go-to guy. The Z estimate of a proportion and the Z estimate of a difference of proportions. Turn the word estimate into confidence interval, and it's literally the same thing. Notice that we don't have T estimates for proportions because proportions don't need T estimates because they have a cap on how big their standard error can be, whereas means don't have that. So this is a weird thing. Now look at what we have. I have a single mean. I know I got it from a weird, I had to do fancy footwork to get here, but I have a single mean and a single standard deviation and a single sample size. So what I need to be clicking on is the T estimate of a mean. Once you have done this work right here, you are back to essentially a single mean, and it works exactly like a single mean does. So you're just going to use a single mean. All right, so let's go ahead. I'm going to choose my confidence level last. My mean, well, let's go back. My mean was 3.375. So let's go ahead and put that in there. 3.375. And notice how things are changing down here. my S, this is my S sub D. And I'm going to cut that off at the 5, so 0.8345. And make sure I copied that correctly. Okay, good. Always double check your numbers. You can, I do want to note, you can go copy, and then if you go file, nope, sorry, edit, paste special, you can go paste value only. And now that it's just the value, up here it's a formula. Now that it's just the value, you can copy, and I just went Control C, and let's see if it'll work. Control V, yeah, and it let me paste the whole thing in there. So that's always a cool thing that you can do, and it did cut it off at 5, which is what I thought it might do. And then and that's one thing I do like about GeoGebra. Now I am working on a regular laptop. GeoGebra is a little bit funny if you have a touch screen. If you only have a touch screen, what I recommend is going and getting a TI-84. You can rent them from student services at school. So if you don't have one, you can go rent one for the term. And that is even if you're not taking a face-to-face class. Okay, so here we go. What I'm going to do, I'm going to take this back to a regular old 95% confidence interval. So let's come down here and let's talk about the things that we have. What has GeoGebra given us? Well, it's given us the mean, and this is just to remind us that we typed it incorrectly. Sometimes if you don't hit enter, GeoGebra will be a little bit weird. This is classic, so it is slightly finicky sometimes. You gotta bear with it. It works great on a regular computer. It's very weird on tablets and phones and Chromebooks. I'm sorry for those of you who have Chromebooks. Okay, so let's go through. We've got our mean, we've got our standard deviation. Notice right here, SE, what does that stand for? That is the standard error, and we can double check that, but actually calculating our standard error over here. The standard error, that's your standard deviation divided by the square root of n. We could say equals the standard deviation divided by square root of our n, hit enter, 0.295, 0.295. Awesome, GeoGebra is doing the work for us. You don't even have to calculate your standard error, it's right there. N, that's your sample size. Degrees of freedom, so if you go back to the student t distribution, remember that it changes based on your sample size. So how big is your sample size is going to change what your degrees of freedom are. In this case, we have degrees of freedom 7. Here is the lower limit of your confidence interval, and here's the upper limit of your confidence interval. So if I go ahead and I'm going to draw with my terrible handwriting, and I'm going to say about 2.6, we'll call it 8, to about 4.07. And I'm just taking these numbers here. So this is my confidence interval when I write it in interval form. If I want it, that's the lower limit and the upper limit. I would say that the difference, and notice it's fully positive, and with the way that we subtracted, that means that the upper arm is the longer of the two. So with 95% confidence, we can say that the average difference between someone's length of their upper arm and lower arm is between 2.68 inches and 4.07 inches, which seems like a lot, but who knows? Again, we have a very, very small sample, and so that confidence interval is pretty big. Over here, we've got 3. Here we have it as the point estimate. Remember, the point estimate is just the statistic that you're using to build your confidence interval around. So for a single mean and a single proportion, it's that single value. For a difference of means, a difference of paired means, a difference of proportions, it's the actual subtraction between those two statistics. So what is the number that you're adding and subtracting to build your confidence interval on? Here, our point estimate is that 3.375. It is D bar. It is the value of D bar. And then this right here, our plus and minus, this is our margin of error. So what are we adding and subtracting on to our point estimate to create the upper and lower limits? Sorry, adding to create our upper limit and subtracting to create our lower limit. So we're adding and subtracting 0.6977, and remember this is in inches, so a little over a half of an inch, or maybe better to say a little under 3/4 of an inch. Exactly 0.6977 inches. And that's it. And so we would say, oops, let me go ahead and clear this. So we would say with 95% confidence, the upper arm is larger, and you could say it's between this much and that much larger, or you can say it is larger, about 3.375 with a margin of error of this much. Kind of have some leeway on how you want to interpret it. Do you want to interpret it with your lower and upper limit, or do you want to interpret it as the point estimate and then let your reader know that this is their margin of error to add and subtract on? I just want to point out that for the other calculators, all of the calculators work. Here is a difference of means. The one thing that you don't want to do is click pooled. For our class, all of our data is going to be unpooled, so you can just go ahead and leave that unclicked. You're going to put the first mean, its standard deviation, its sample size. Second mean, its standard deviation, its sample size. Notice it's carrying over my data from my previous one. If you accidentally click on Z estimate, oh, hey, oops, I've done the wrong thing, you can go ahead and click on the T estimate. And you can change your confidence level to any level that you need. For proportions, here's one thing that it does not want P hat. What it wants is your number of successes and your number of trials. Now notice this doesn't make any sense carried over. It says 442 successes out of a trial of 8. That's not possible. Your successes must be smaller than your total number of trials. Remember, the term success here is a little bit weird. It comes from the idea of statistics was originally from gambling, and so they had success and failure. We carried that on. So success is really the number of things that you're curious about. So the yes column, if you will. It's a weird choice of word for ourselves. Oftentimes we denote it with an X. So be a little bit careful about that, because there's X, the number of successes, versus X bar, which is your actual mean. So X's are for proportion and X bars are for means. Same thing here, differences of proportions. You just need successes and your trial size. These have to be whole numbers. So when you go back to figure out your number of successes by multiplying n by p hat, and you get a non-whole number, you just want to round to the nearest whole number, and that will get you there correctly. Okay, and that is how to use the GeoGebra confidence interval calculator, and also what does it mean when you're doing paired means.